All right, so taking a look at your 8.4 notes, this is what we discussed yesterday. Let's look at the back side here. I just want to work a problem or two here. Okay, let's take a look at this first one. So, the problem states, to approach runway 17 of Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airplane at the start of this approach? All right, so we have to set up a problem, okay? So first off, we should probably have the ground. All right, and we have an airplane. Okay, so let's do a quick airplane. There's my airplane. And we have an airport. I'm just going to go like that. There's my airport. Okay? You don't need to have super big detail, all right? Approaching runway 17, Ponca City Municipal Airport in Oklahoma. That doesn't mean anything to us. We don't need to draw that part. Let's see. Everything else is actually fairly important stuff. Okay? So don't get lost in the details. All right. So we have to somehow figure out how to draw a triangle here. Okay? We want to know, to the nearest tenth of a mile, how far from the runway is the airplane at the start of the approach? Well, we know that the pilot is making a 3-degree descent, starting from a height of 2,714. Okay, well, there's a couple of things they're talking about here that we have to make sure to have straight. The airplane's height is 2,714 feet above sea level. How high is the airport above sea level? 1,007. So in your mind, is this airport like floating in the air? No. The airport's on the ground, right? And you guys understand that the ground is, of course, above sea level. Why does water run downhill? Because of gravity. Why does the river run to the Gulf of Mexico? Because of gravity. We are above sea level. Okay? And so things are measured above sea level. And so we have to do a little bit of calculation to make our triangle. So our triangle is going to look something like this. Okay? There's our triangle, but we have this extra information. We know that this distance is 2,714. But we know that this distance is 1,007. All right, because the airport is 1,007 feet above sea level, but the airplane is 2,714 feet above sea level. So my question to you is, what is this distance in that red part of that triangle? What is the height of the airplane above the airport? What is the height of the airplane to the ground? How do you find it? Some of you are grabbing your calculators. What are we doing? Subtracting what?
2,714.
Right, we need to take 2,714 minus 1,007. And what do we get? 1,707, right? All right, so this is 1,707. Okay, so that is the height we need to use for our airplane in our calculation. Okay, good. Well, next, we have more information. We know it's a 3-degree descent. So if they're flying horizontally and they start to descend, what type of angle is that? angle of depression. This is a 3-degree angle of depression. We want to know, to the nearest tenth of a mile, how far from the runway is the airplane at the start of the approach. So here's the question. In measuring distance like this, it can get confusing as far as what they're talking about here. Okay, it can get confusing. What are we trying to calculate? Are we trying to calculate the adjacent side, or are we trying to calculate the hypotenuse? Now again, here's one of those things. You got to get out of your head for a moment, like I was talking about before. All right? They're saying, what is the distance to the airport for this plane when it starts its descent? Which are we looking for? The adjacent distance or the hypotenuse distance? What do you think? That's a good guess, because that would be very similar to the balloon problem, right? That weather balloon problem where it was doing a radio signal for distance. You guys have seen radar screens before, probably on TV or things like that, but you guys know what I'm talking about when I'm talking about a radar screen, right? You guys understand satellites? Satellites being way above us, looking down at us, right? Can the satellite ever look at the side? No, satellites look straight down all the time. So air traffic control, they are trying to figure out, they have all these airplanes that they're looking at. Are they looking at it as a side view like we have right here? No. They're looking at it straight down. Where are these airplanes? And of course, they know different elevations. But they are not doing a direct line of sight distance. They're actually going to be doing a horizontal distance. This plane is at, say, 20,000 feet, but it is how many miles away from the airport at 20,000 feet. They're asking for that horizontal distance to the airport. Okay? They call that the ground distance. The ground distance. All right, so again, we got to be careful on what we're calculating. So to the nearest tenth of a mile, how far away from the runway is the airplane at the start of its approach? We are then looking for that value x up there, that horizontal ground distance to the airport. All right, so now that we have this figured out, which trig ratio are we going to use from SOHCAHTOA? Tangent. We know the opposite leg. We're looking for the adjacent leg. So this should be the tangent of 3 degrees equals the opposite leg over the adjacent. There's that situation I was talking about. X is in the denominator. My preferred method for solving that is to switch the tangent and the x in my proportion. So I end up getting x over 1 equals 1707 over the tangent of 3 degrees. So when you plug that into your calculator, what do we get? Who's going to be brave and tell me the answer to 1707 divided by the tangent of 3 degrees? Are you going to be brave and say it for everybody? 571.5, roughly, approximately. Everybody getting that? Okay. Does that sound right? So 32,000 miles away, or because that's what we're doing, right? How many miles in there is tenth of a mile? So they're saying 32,000 miles away. Any concept of how far away that is? It's not even in the United States anymore. Okay? That's possibly over the ocean, if not in a whole other continent. Okay? So, that's not working for us. That's not working for us. Why? Because that calculation is not in miles. All of our dimensions were given to us in feet. So that calculation is in feet. Okay? So 32,000 feet, okay, that makes more sense. But now the question is, how do we change that into miles? We need to know a conversion. If you're at home working this problem, and you don't know how to convert feet into miles, what should you do? Look it up. Say, Google, how many feet are in a mile? Or say, Siri, how many feet are in a mile? I always like doing that, find out whose phone's on, whose phones are listening to me. Nobody yet. Okay. So, Siri, how many feet are in a mile? Anybody know that one? 5280. 5,280 feet per mile. So, what are we going to do? We're going to take this value and we are going to divide that by 5,280 feet. So that now will give us our answer. X is approximately, did you say 6.5?
Yeah.
6.2 miles. And that makes a whole lot more sense. Okay, that makes a whole lot more sense. 6.2 miles. And we see that all the time. We see that all the time because we live, of course, next to Offutt. And so you guys always see airplanes flying by, going to land at Offutt, right? Do you ever notice that their approach, you can see them kind of lining up with the runway over La Vista? Right? You know why? La Vista's roughly 10 miles away. A little closer. So it's right in that same range of 6.3 miles. They're getting themselves lined up. They're going to start their descent. Okay? All makes sense. Questions? These problems are no different than all the SOHCAHTOA stuff we've been doing. What you need to do now, though, is make sure to set it up right. Think through the problem. You guys have the knowledge to do this. You just got to slow down and think through the problem. Okay? So let's give you guys some time to work on homework at the end of the class.